Students, welcome to my video class. In this session, let us discuss thermodynamics. In the beginning, I will introduce you my plan. For a couple of videos, I am going to share you the tricks, concepts, previous questions from the thermodynamics. I have noticed that many students find it difficult solving thermodynamics questions. It is because thermodynamics involves numericals, interlinking concepts, and some practical ideas. Therefore, thermodynamics should be understood from overall perspective. Hence, I have made these videos after checking all previous question papers and selected repeated questions, and I divided the chapter into small videos based on concepts and previous questions. Therefore, watch all the videos. I assure you will get a clear idea from the thermodynamics, and it will help you to solve every questions from the thermodynamics. Okay? Okay, let us watch first content video. Here I would like to discuss various thermodynamics processes. Okay, you please watch this, how I connected this title with the entire chapter. This is very important. I have picked up all the ideas from the entire chapter to this title. Let us see how is it possible. The first is, as we are familiar, isothermal. What is isothermal? In the isothermal, there are processes which is equal to 0, which is not equal to 0. Okay, delta T is equal to 0, delta U, internal energy is equal to 0, delta H is equal to 0. You know, internal energy is always a function of temperature. Enthalpy is always a function of temperature. Okay? Normally, for a thermodynamic gaseous system, internal energy and enthalpy are function of temperature. Once temperature is 0, all these are zeros. Temperature change is 0, all these are zeros. But you know, delta S not equal to 0, delta G not equal to 0, and delta A, Helmholtz free energy, are not equal to 0. Entropy of expansion. What is delta S of entropy change during isothermal expansion? What is that? It is nothing but NR ln V2 by V1, or 2.303 NR log V2 by V1. Fine. There is no T. What is delta G? Delta G is equal to minus, because during expansion entropy increases. Remember, during expansion entropy increases, but free energy decreases. Negative. For an idea, NR ln nRT ln V2 by V1. nRT ln V2 by V1. Or delta G is equal to minus 2.303 nRT log V2 by V1. Fine. Delta I am not going to details of the equation delta I. You know why? Delta G is equal to delta H minus T delta S. This is 0 for an isothermal process. Therefore, delta G is equal to minus into this minus and T. Am I correct? This is our delta S. NR ln V2. Put this here, T. You will get this. Correct. Very simple. Therefore, remember this. Delta G is equal to delta H is equal to 0 minus T delta H. Okay, for an isothermal process, you have all these criteria. Particularly isothermal and reversible. Isothermal and reversible. Okay, we will solve the question. For an isothermal reversible, entropy change is this. Free energy change is this. This is expansion if V2 is greater than V1. Expansion if V2 greater than V1. Compression if V2 less than V1. During the expansion, entropy positive and free energy negative. During the compression, entropy negative but free energy positive. Okay? For gaseous system. I think this is clear for you. Now we will go to adiabatic process. Adiabatic processes. Fine. Adiabatic process. Adiabatic process, Q is equal to 0. There are where E is equal to 0. Generally we know that Q is equal to 0. Particularly reversible. Remember, delta S also 0 because delta S is equal to Q by T. But you have some process which is not is equal to 0. What are they? Delta H not is equal to 0. Delta H not is equal to 0. Delta U not is equal to 0. Delta G not is equal to 0. Delta N not is equal to 0. Delta A is Helmholtz free energy. What is delta H? Delta H is equal to, for an adiabatic process, delta H is equal to VdP, delta U minus PdV, this is also VdP or V delta P for an adiabatic process. You know, delta H is equal to delta U minus plus PD delta V or plus V delta P. Or delta U is equal to Q minus P delta V. Put this. Therefore, your delta H is equal to Q minus P delta V plus P delta V plus V delta P. This and this cancelled. Q is also already 0 for adiabatic process. Therefore, delta H is equal to V delta. Delta G also V delta V. Why? Because delta G is equal to delta H minus T delta S. This is 0 for adiabatic process. Therefore, delta for adiabatic process, delta G is equal to delta H. Okay? Is this idea okay? Okay. Therefore, for a reversible adiabatic process, these two are 0, these three are non-zeros. Okay? For a delta U, Q is equal to 0, therefore delta U is equal to minus P delta V. Okay? Yes. Now, third is, as usual, isochoric, delta V is equal to 0. Isobaric, delta P is equal to 0. Isochoric, delta, okay? Isochoric, delta U is equal to 0. Delta V is equal to 0. That is, for an isochoric, delta, we know that delta U is equal to QV minus P delta V. For an isochoric process, delta U is equal to QV, where delta U is equal to QV. For an isobaric process, delta P is equal to 0, where delta H is equal to QP, or delta H is equal to QV plus PdV, QV PdV, QV into PdV, where QV is equal to delta U. Okay, am I correct? Yes. For isobaric process, therefore this is isochoric process and this is for isobaric process. Now we can go to next, cyclic process. Cyclic process. Cyclic process. For cyclic process, we have state functions and the path functions. Path functions. State function, temperature, pressure, volume, internal energy, enthalpy, entropy, free energy, Helmholtz free energy. All our changes are 0. Delta T is equal to 0, delta P is equal to 0, delta V is equal to 0, delta U is equal to 0, delta H is equal to 0, delta S is equal to 0, delta G is equal to 0, delta A is equal to 0. Path function Q and W, Q naught is equal to 0, W naught is equal to 0. Okay? But for a cyclic function, suppose a cycle, reversible cycle and irreversible cycle, very very important. Work reversible and work irreversible. Which is higher? This is higher. Because always reversible work greater than irreversible work. Irreversible work. Okay, we learned that. Irreversible work is, amount of irreversible work is less than reversible work. It may be expansion or compression, whatever it is always greater than this. Therefore, both are is equal to, not equal to 0, but reversible work is greater than irreversible work. Both are not equal to 0, but magnitude is higher. This Q also. Q reversible and Q irreversible are there. Both are not equal to 0. Q reversible and Q reversible not equal to 0. Q irreversible not equal to 0. Okay. Yes. Now, let us discuss some questions from these topics. What are the previous questions? Okay. Okay, let us take first question. Okay. I will write the question. In an isothermal reversible, let me check the videos. Okay. In an isothermal reversible, compression of 1 mole of an ideal gas in which the pressure of the system increased from 5 atm to 30 atm at 300 Kelvin. At 300 Kelvin. In an isothermal, what is the entropy change? Entropy change. In an isothermal reversible compression, entropy change of an isothermal reversible process. Isothermal entropy change. What you have learned? Delta S is equal to NR ln V2 by V1. That is 2.303 NR log V2 by V1. In terms of pressure, it is 2.303 NR log P1 by P2. In terms of pressure, no problem. Very simple. Okay, very simple. What is answer? 2.303 1 here 1 mole into 1 8.314 into log. What is P1? From pivot initial 5 atm. Okay. Yes. From 5 by 2 P2 30. Yes. Minus 2.303 into 8.314 into log 30 by, that is log 6. Log 6. Okay. Here a negative value you will get. Because in the compression entropy decreases. During the compression entropy decreases. Okay. I hope this problem is okay. Now we can go to another problem from a previous case. Yes, very good. A question asked me, what is or are current during isothermal free expansion. What is the meaning of free expansion? Well, W is equal to 0. Options. Delta U is equal to 0. W is equal to 0. Q is equal to 0. And for delta H is equal to 0. What is or are current during? During free expansion means W is equal to 0 because expansion without the expense of any energy. Expansion towards work. Okay. You are doing a work without the expense of any energy. That is called the free expansion. Therefore, this is correct. Isothermal, it is mentioned isothermal. Therefore, delta U is equal to 0 and delta H also 0. Delta U is equal to 0, W is equal to 0 and delta H is equal to 0. I think it's okay. Now we can go to another question. Question number 9. Very, very simple question. Question is this. Third question. 2 moles of an ideal gas is expanded isothermally and reversibly from 5 bar to 1 bar at 298 Kelvin. What is delta S? Again, same question. Delta S, isothermal, 2.303 NR log V2 by V1, that is P1 by P2. Well, same question. That is 2.303 into 2 into 8.314 into log 5 by 1. Very, very simple. Very, very simple. Okay. Yes. Now, next question. Next question. One mole of an ideal gas subjected to an isothermal increase in pressure from 100 kilopascal to 1000 kilopascal at 300 Kelvin. What is change in free energy? Students, don't confuse. Isothermal. Focus on the word isothermal. Isothermal free energy. What is the equation I have introduced you? Delta G is equal to minus 2.303 nRT log V2 by V1. If it is in pressure, minus 2.303 nRT log P1 by P2. Don't worry about it. Okay, minus 2.303, 1 mole, that is 1 into 8.314 into T, 300 log, what is P1? 100, P2, 1000. Just reverse. 2.303 into 8.314 into 300 into log 1000 by 100. Minus will disappear, minus will remove when you interchange it. That is log 10. What is log 10? 10. 1. Therefore your answer 2.303 into 8.314 into 300. That is your delta G. Delta G is positive here. Why? Because it is compression from lower pressure to higher pressure. That is, free energy will be positive when you compress, entropy will be negative when you compress. Therefore, my trick, this is my trick. If there is a word isothermal and reversible, students, this is a trick. Delta U is equal to 0, delta H is equal to 0, delta T is equal to 0. But delta S is equal to nR ln V2 by V1. Delta G is equal to nRT minus nRT ln V2 by V1. Ln, convert into log, or delta S is equal to nR ln P1 by P2, or delta G is equal to minus nRT ln P1 by P2. When you convert the ln into log, you will get 2.303 log. Very, very simple. What is the key word? Isothermal reversible. Therefore, when you say isothermal reversible, at constant temperature, sometimes there will be a word at constant temperature. They will not mention isothermal, but at constant temperature. At constant temperature. Entropy and free energy calculated by this equation, these are not to be calculated because they are 0. Fine? Okay, I think this is okay for you. Thank you for watching. And I will go to another topics from the thermodynamics in the next videos. The entire chapter will be discussed in this capsule-like manner. Follow me, subscribe this, and you will be I assure you, you will get a full mark from the thermodynamics. You can solve every question from the thermodynamics because I have selected question from previous question papers. Okay? Yes, let us move together. Thank you.